Good day. For those of you who do not know us, we are the instructional staff for ECE 150, Professors Hiran Patel and Verna Dietl, and Douglas Harder. In this topic, we're going to look at the scope of local variables. So in this topic, we are going to introduce the concept of scope for local variables. We will see the effect of using local variables outside of their scope. Specifically, it's going to result in compile time errors. We will explain why the scope of local variables is restricted, and we'll look at a common mistake from first-year students. As a motivating example, consider the following program. Here we have a for loop where the loop variable k is initialized with the value 4 and the loop body is executed so long as k is less than 7. After the loop, the value or local variable k should equal 7, so I would like to print that at this point. Thus, this should produce the desired output of 4, 5, 6, 7. Problem. Before you even execute this function, when you try to compile it, you get a compile time error. The error message may vary depending on which compiler you're using, but it's going to read something like this. On line 13, at the 18th character is something wrong. Specifically, k was not declared in this scope. The error message says that k is not declared. But wait a second, it was declared. It was declared in the initialization statement in the for loop where we used it, and it should work. Consider, for example, the following program. Here I have a default value that is initialized with a value 0. I then query the user, do you want a value different from the default, which I then display to the screen. I indicate to the user, enter 1 for yes and 0 for no. I then store the response in the local variable useNew. Now, if useNew is true, then I query the user to enter that new value. I store that new value in the local variable newVal. I then print that value to the screen. So I guess what I'd like to happen is, would you like to use a value different from 0? The user enters 1. I ask the user to enter that value. The user enters 17. I should then be able to print the value 17. But problem. When we try to compile this program, once again we get an error message that is similar. The error message says that the identifier newVal was not declared. And yet, it was declared and used in the conditional statement. To avoid confusion, and we'll look more into the reasons for that later, a local variable can only be accessed from where it is defined up until the end of the block in which it is defined. So, for example, suppose inside main we have this conditional statement. We run some code and declare a local variable isFound. We can only access or assign to that local variable after it is defined up until the end of the block in which it is defined. That is, up until the closing brace corresponding to the consequent body of this conditional statement. After that conditional statement is finished, it cannot be accessed or assigned to from that point on. If the local variable is needed outside the conditional statement for whatever reason, it must be defined before the conditional statement. So, for example, in this case, I've declared isFound before the conditional statement. Then inside, rather than initializing isFound with the value false, I assign it the value false. Then I can use that local variable and I can continue to use that local variable outside the conditional statement. So that part of the program where a local variable can be accessed or assigned to is described as the scope of that local variable. If you try to access or assign to a local variable anywhere else, the compiler will indicate that that identifier is not in scope. One of the most common sources of such an error is a typo in an identifier name. Suppose, for example, you use the American spelling color intensity as the name of a local variable, but then elsewhere you use the English spelling for the same word. In this case, the compiler will not know that these refer to the same local variable and instead will indicate that the second is an undeclared identifier. It is not in scope. Now let's go back to this motivating example. Here we have a for loop. The loop variable k is restricted in scope to the for loop itself. It cannot be accessed before or after that for loop. So this is the scope of the loop variable k. And the output of this program is 456. If it was absolutely necessary to access that loop variable outside of the loop, then it would be necessary to declare it first, and then in the initialization statement, rather than declaring the variable and initializing it, I will simply assign the loop variable k the value 4. Then the loop continues to run so long as k is less than 7. However, once the loop is finished, the local variable k is still in scope, and so I can continue to print it. Thus, the output is 4, 5, 6, and 7. Here's something that's a little bit more awkward, but it's still valid. I have both declared and initialized the loop variable here. So its value is 4. The initialization statement of the for loop is now blank. Now that's a little bit awkward because a reader of this for loop no longer knows what the initial value of k is without looking back up somewhere else in the program. So this really isn't a good idea. However, you may indeed see this, and this is valid C++ syntax. So once again, the output is going to be 4, 5, 6, 7. To consider an example where using a local variable in a restricted scope is useful, consider this program. I'd like the user to enter a number of values, and I'd like to store the maximum of those values that were entered. Now, I'm going to require that the user enter at least one value, so if count is less than 1, I will just set count equal to 1. I will then store a value or have a local variable maximum, and whatever first value the user enters will be stored in this local variable. Now, carrying on, I have a for loop. The for loop starts at 2 and continues up until k is equal to count. In this for loop, I have a temporary variable, and so the second, third, and subsequent values entered by the user are temporarily stored in this local variable. If this local variable is greater than maximum, I will assign maximum to be that value. At this point, the local variable maximum is in scope, while the local variable temp is now out of scope, as is the loop variable k. I can then indicate the maximum value that was entered and subsequently use that local variable. We only needed the loop variable k and the local variable temp inside the loop. What's nice here is the user who is reading this code sees that these two variables are only required within this restricted scope and do not play any significant value outside of that for loop. So one way of solving this problem is to simply declare all your local variables at the start of the function main. So here are all the local variables. You could do this. However, this is actually poor programming practice. And if you were to submit this in code, say, to an interviewer for a co-op job, that interviewer might take a second thought about actually hiring you. So it's not necessarily a good idea. There are problems with such an approach. The reader of your code does not know which local variables are important and which are just temporary. Well, technically they're all temporary, but some are more temporary than others. It also makes it much more difficult for a reader to read through your code, because now the reader must know all local variables with all their initial values right off the bat. With local variables declared near the top, the reader is going to say, these seem to be important. With a local variable that's declared only in a for loop, the reader can say, these are used here and nowhere else. So once the for loop is done, the reader can ignore the values stored in those local variables. Also, if you declare all local variables at the start of the function, you may accidentally use a local variable after it's been declared, but before it has any useful meaning. That is, before it is assigned a value of significance. Alternatively, in a larger program, you may accidentally reuse a local variable when you should not. Now, there are some issues with declaring local variables. You can never declare a local variable twice in the same block. In general, actually, you should never use the same identifier twice in the same function ever. If, however, you were to declare an identifier to be a local variable twice, once in one block and once in a different block, the closest one is the one that is used. Okay, now, as an example of a common mistake that I have seen, here we see the identifier value being used twice as a local variable. First, immediately in the main function, value is declared to be a local variable of type int. So then, we query the user for a value, and we call console input to store that value entered by the user in this local variable. Now, if value is less than or equal to 0, then we indicate to the user that the value that was entered must be positive. This identifier value continues to refer to the previous local variable declared at the start of the function main. However, the student just cut and paste the same block of code approximately and accidentally redeclared the identifier value to be of type int. Well, as far as the compiler is concerned, this is now a new local variable that is independent of the first local variable named value. So now, when we call console input, the new value entered by the user is stored in this new local variable. And when we access that local variable, we print that new local variable. However, because that local variable was declared inside the conditional statement, as soon as we exit the conditional statement, that new local variable goes out of scope. So at this point, we are back to using and accessing the local variable declared immediately after the function main. So if we were to take this function or this program and run it, enter a positive value. Suppose the user enters -5. We tell the user -5 must be positive. Suppose the user obliges and gives us the value 17. Great. We now print. You just entered 17. However, the second print statement at the bottom now once again says you entered -5. Following this topic, you now understand the concept of the scope of a local variable. You know that the scope of a local variable ends when the block in which that local variable is declared ends. You are aware that in general, local variables should be defined only when and where they are likely to be used. You also understand that while a local variable cannot be declared twice in the same block of statements, the compiler will allow you to declare an identifier to be a different local variable a second time in a block of statements within a block of statements. Say, for example, as we saw, within a conditional statement or within a for loop. You realize, however, that it's probably a really bad idea to use the same identifier for two different local variables inside the main function.